Alright guys, here is your first video lesson, and that is 8.4. We're just going to do two examples. They're a little bit involved, but we're going to do two quick examples to get you guys started on the 8.4 homework, and then we'll finish this the next time. You'll watch this the following time before we meet again. Okay, so just really quick before I get into graphing rational functions, I need to do a quick review. And that is a review of the word degree. So if I have an expression here like this, x to the third plus x squared plus 1 or something like this, hopefully you remember that this thing has a degree of 3. The reason for that is the highest exponent in any of the terms is 3. Okay, so it has a degree 3. If I had something like this, x to the 6th plus x plus we'll do x squared plus x plus 1. The degree of this one would be 6, right? Because it is the highest exponent within the expression. So that's just a quick review because you're going to need that today for your asymptote rules, which we're going to talk about right now. So there are 3 rules for asymptotes. One of them we've already talked about, which is the vertical asymptote. Okay, that's just whatever makes the denominator go to 0. Okay, so I'm going to give you guys an example here just to use for all of these rules. Let's just use this, x squared plus 1 over x, something like that, something simple. Okay, so what makes this go to 0, the denominator go to 0 here? Well, if you plug a 0 in, right? So in this case, the vertical asymptote would be 0, all right, in our example. I think you guys should be familiar with that, but let's move on to the second rule, which you probably are not very familiar with because we haven't really talked about it yet. That's the horizontal asymptote. Okay, so there's at most one horizontal asymptote, all right? With vertical, we can have multiples, but with horizontals, we'll only have one. There are 3 possibilities for the horizontals, okay? So I should let you guys know that how they've defined all of this, when you see this ax and bx, essentially what they're saying when they're talking about this is that the numerator, they're calling the numerator function a, and they're calling the denominator function b, okay? So when you see that, that's what they're referring to. So with rule number 2, horizontal asymptote, part A, it says if the degree of A, or the degree of the numerator, is greater than the degree of the denominator, then we do not have a horizontal asymptote. Okay, so in my example here, since the degree of the numerator is greater than the degree of the denominator, because numerator is 2, denominator is 1, there's not going to be any horizontal. Okay, so there would be no horizontal in our example. Okay, so the second rule with a horizontal is if the degree of A is less than the degree of B, then it is equal to 0. An example of this I will give you here in purple would be something like this. If I had x over, well, if we just flipped it, x squared plus 1. So if the degree of A is less than the degree of B, which it would be here, right? Because the degree of A here is 1 and here is 2. Then we have a horizontal asymptote at 0. Okay, so if you were to graph that, the horizontal asymptote would just be right here on the x-axis. Okay, then the third possibility is if the 2 degrees are equal, then we have the leading coefficients that we look at. So let me give you an example for that because that could be confusing. So for this one, if the degrees are the same, okay, so if we have let's just say we have x squared plus 1 and then we have x squared minus 3, something like this. Okay, notice that we have, and actually let's change this up a little bit. Let's do 2x squared plus 1 on the top. Okay, so notice that the degree of the numerator and the denominator are the same. This is degree 2, this is degree 2. Okay, so we're looking at rule C whenever that's the case. Okay, to figure out what the horizontal asymptote is, what we do is we take the leading coefficient of A over B. So the leading coefficient, just to review on that term, is just the number out in front. Okay, so the number out in front in this case would be 2 over 1, which equals 2. So you would have, if you were doing this one, the horizontal asymptote would be, if we were actually looking at this one, the horizontal asymptote would be at 2. So at 2, you would just draw in a horizontal asymptote. Okay, so I did that in green there for you guys. The third thing that we're really going to focus on more next time, but I'm going to give you the rule right now, is the oblique asymptote. This is an asymptote that is kind of a line that has a slope. Okay, so let's change colors again here. We'll do this in blue. So for number 3, we'll do it in blue, just so no one gets confused here. So it says if the degree of A minus the degree of B is exactly 1, then the equation of the asymptote will be whatever that thing is. Okay, so what that looks like is this. If you look at the original example here, the degree of A is 2. The degree of B is 1. If we subtract them, we get exactly 1. That's what this is talking about. Okay, so this thing does have an oblique asymptote. What the oblique asymptote is just this division problem. Okay, and we don't worry about the remainder for that. Oops. Get back in there. So what this would look like if we were doing this one up here, what it would look like is this. We would take x squared, let me get this in blue again, x squared plus 1, and we would divide it by x. So a little bit of review on the division here. X goes into x squared, x times x is x squared. We subtract, we get 0, we bring down the 1. X goes into 1. Well, x can't go into 1 because there's no x's. So that would be a remainder, so we don't worry about it. So the oblique asymptote would be at y equals x. So if we were going to graph that oblique, and don't worry about this too much right now, but we'll do some more of this later, it would look something like this. There'd be an oblique that goes y equals x, which is just a line with a slope of 1. Okay, so those are our asymptote rules. We'll refer to those often. They give you guys a couple of examples here, which I encourage you to look at. I think I give these to you in your notes. Notice whatever makes the denominator go to 0 is the vertical asymptote, right? On this one, if you plug a -1 or a 1 into this for x, you would still get 0. So this one has 2 vertical asymptotes. And then just to say a little thing about the horizontal here, since the degree of A is less than the degree of B, we know that that's rule B. Okay, so looking back up here, we're looking at rule B. Okay, so this one fulfills rule B, which means that we have a horizontal asymptote at 0. And then looking at the final one, what makes the denominator go to 0 is 3, so that's our vertical. And then the horizontal is going to be, since we have the degrees are the same, it'll be 2 over 1, which equals 2. And again, this is because the leading coefficients of the leading term is 2 and 1, 2 over 1. Okay, so to graph these things, you guys. And I know I'm going pretty fast, but I'll answer questions in class. Steps to graphing these. Step 1, you always want to find out where your zeros are. Okay, that's where the graph crosses x. And this will always happen with whenever the numerator goes to 0. Okay, so we're going to factor often the numerator and see what makes it go to 0. That's step 1. Step 2, we're going to draw in the asymptotes. We have the rules for those. Step 3, we're going to make a table, plug in x values, get y values out, then we're going to graph the points. So to save time, I've already created our xy tables. Okay, I encourage you to add to them and to do more with them, and I'll show you how I got those numbers, but to save time, I've already done it. So let's just go through the steps. Okay, so step 1 is, what makes this go to 0? So if you remember this from Algebra 1, what you have to do to find out what makes this go to 0 is factor it. So if you factor this, you're asking yourself what multiplies to give you -6, adds to give you -3. Well, the factors of 6 that have a difference of that 1, I hope I said -1, but anyway, the two factors that work for this thing would be x -3 and x plus 2. Because -3 times 2 gives you -6, and -3 plus 2 gives you the -1. Okay? And if you FOIL it out, you should get the same thing back. So another way to write this problem would be like this. Okay, so we have a vertical asymptote at -1. We have zeros, which I'm going to fill in here, at 3 and -2. That's because 3 and -2 makes these go to 0. Okay, so I'm going to fill those in right now. So I know that I have a 0 at 3 and a 0 at -2. And I also know I have a vertical asymptote at -1. Okay, since the degree of A is bigger than the degree of B, following our rules up here for horizontals, looking at rule A, then we know there's no horizontal asymptote. So there's no horizontal. Okay, so the next thing we're going to do is we're going to make a table. So I've already made a table for us. And I'll do one of these with you guys. I'll show you how I got these numbers. All I'm doing is I'm choosing values that are on the left side of this asymptote and the right side of this asymptote to see what happens on either side. Okay, so I chose -3, -2, -1, 0, 1, 2, and 3. You guys can choose more values than that. This would probably be like the bare minimum. But you want to choose values on either side of the asymptote so you can see what the graph is doing on either side. Okay, so to get the -3 here, I'm just going to show you the first one, and you guys can do the rest of them on your own. So what I did was I just plugged it in. So -3 squared minus -3. Notice how I use parentheses. -6 over -3 plus 1. When I do this out, -3 squared is 9. 9 minus -3 is 9 plus 3 minus 6. Okay, and then my denominator simplifies to -3 plus 1, which is -2. Okay, so 9 plus 3 is 12. 12 minus 6 is 6. So we have 6 over -2, which equals -3. That is how I got the -3 in the chart. So now I'm just going to plot these points that you guys see on the chart. So at -3, I'm going to put a point at -3. At -2, I already have one at 0. At -1, I'm at my asymptote. Okay. I would encourage you to figure out what happens at -6. All right. But I happen to know that it's going to do something like this. All right. And then on the other side, let's plot our points. So we have 0, -6. We have 1, -3. We have 2, -4/3, which is -1 1/3. And then we know that we have a 0. So it looks like it's going to do something like this. Okay, and again, I encourage you to maybe find out what happens at 6. Just to see what happens to the graph later on. But that's it. They're just looking for you guys to sketch a graph like that. So that's 1A. Okay, here is 1B, so we'll do one more together. Again, I would want to know what makes the numerator go to 0 so I can put that on the graph. And the only thing that makes that go to 0 is -1. So at -1, I must have a 0. To find my asymptote, for my vertical asymptote, what makes the denominator go to 0 would be -2. So at -2, I have this vertical asymptote. Okay, those two things are important to figure out beforehand before you make this chart. This chart now should include numbers that go to the left of this and to the right of this. Okay, so I chose some here, so I'm going to plot those for you guys. And again, degree on the numerator is bigger than the denominator, so there's no horizontals for 1B. Okay, so at -4, we get -6 3/4. So I believe that is somewhere in here. At -3, we're at -8. And I happen to know that this is going to get really close to this asymptote, but then it also falls off this way somewhere. So I would encourage you to plug in a point, maybe -7, to see what happens. Just to see where that final point is. Then to the right, So at -2, we had the asymptote. At -1, we had the 0. And then at 0, we had 1/4. Okay, if you plug in a 2, you get 27/16, which is like 1 and whatever that is, for whatever, 1 and 11/16. So it's somewhere in here, but on the 2, so like this. Okay, so for 1b, I happen to know that this is going to always approach this asymptote. Okay, so we're going to do something like that, and then does something like this. And I would encourage you to plug in a 6 to see where you're at like 6. Okay, but for the sake of time, I'm just going to breeze through that. And again, all I'm doing is I'm choosing values and I'm plugging them in. Okay, so to show you the first one, I just plug it in a -4. Okay, something like that. -4 plus 1 is -3. -3 cubed is -27. -4 plus 2 is -2. -2 squared is 4. So 4 goes into -27 -6 times. And then you have 3 left over. So that's how I got the -6 3/4. Okay, you can also do that on your calculator and convert it to a decimal. That's fine too. All right, so the last thing that we're going to do together, you guys, is example 2. All right, so we're talking about a company using this formula to figure out salaries for employees, where X is years. Okay, so then it says what domain and range make sense for the problem and what's the meaning of the asymptotes. Okay, so first of all, if X is years, I always look for vertical asymptotes first. The vertical asymptote here is at -1. Well, since X is talking about years, we can't have a -1 year, so we're not going to worry about the vertical asymptote. Let's look at the horizontal though. So horizontal, we have the degree of the numerator the same as the degree of the denominator. What that means is we have to follow the rule C. So we're looking at rule C for horizontal asymptotes, which is the leading coefficient rule, which means the horizontal asymptote for this thing would be 45/1 or just 45. So at 45 on this graph, I have a horizontal asymptote. Okay, so technically if I choose values to plug in, I should never cross that horizontal. So that's kind of a guide for us. Okay, now what I'm going to do is I'm going to plug in numbers for years. So say you just get the job. So you're at year 0, you have no experience. You plug a 0 in. For X, you will be at 25. Because 45 times 0 is 0 plus 25, so we have 25 on the numerator and 1 in the denominator. Okay, so that's just how I'm getting these numbers. So I have a dot here. Plug a 1 in and you'll be at 35. Plug a 2 in, you'll be at 38 1/3, which is somewhere in here. Plug a 3 in, you're going to be at 40. And then I plugged a 10 in, and at 10, we're going to be at 43. Okay, so somewhere in there. Okay, so we have this kind of graph. Okay, so then it says, what domain and range values are meaningful in the context? Okay, so for the domain that's meaningful here would be, let's see if I can get this pen to work. The domain that's meaningful here would be, so it's possible X values, so it would be positive values. You could say something like positive values less than 50, because who really works longer than 50 years at a place? But don't worry about it. Just say positive values. Then for range, a range that would make sense, well, at year 0, you're starting at 25, and you never go beyond 45, right? So your range would be between 25 and 45. Okay, and the horizontal asymptote means, the meaning of that thing would be that, you know, your salary, no matter how long you work there, it's never going to go over 45,000. So that's kind of what it's asking you for the meaning of the horizontal asymptote. It's just saying salaries will never go beyond that 45. Okay, guys, that's all for this time. We'll pick up with part B next time. Feel free to go back in the video if you need to review any of this stuff. Be sure to fill out your notes. And you should be able to do a lot of the homework now for 8.4, including some example 3 stuff. Example 3 is really not much different than 1 and 2. We're just going to break down the oblique asymptote just a little bit more. So don't worry about it too much. As long as you put in enough values for your charts, you can probably do most of the homework. All right, guys, we'll see you on Zoom.